Okay, so this lesson title is Mutation and its Role in Genetic Change. So this is for year 12, the New South Wales syllabus in Australia. So this would be the NASA Focus Outcomes Bio 12 2. So 1212 and analyzes the biological factors that affect the continuity of species. And then Bio 1213 explains the processes and outcomes of evolution. All right. So as with every lesson, I will go through the learning objectives. So therefore today, the first is for you to define mutation and distinguish between gene and chromosomal mutations. Analyze the causes of mutations. So for example, mutagens. And third, evaluate the role of mutations in natural selection and evolution. And lastly, apply your understanding through a case study. So in this case, we're going to do antibiotic resistance. Okay, so let me just go through the DNA typo analogy first. So what we're going to do is to engage you. The DNA typo analogy here. All right, so I do have a very quick prompt that I can bring here. Okay. So imagine your DNA has a giant recipe book. What happens when there is a typo in one of the recipes? So I want to have you think for a second. So I want you to think about mutation as a typo in the genetic code. All right, so if you have a giant recipe book, so if you have one of the ingredients, so for example, you have on the thin, if you have in DNA, for example, if you have A, T, C, then after your mutation, you have A, G, C. So if something is changed, that is called a mutation. Okay, so it's a very simple concept. Now, let me go back to the lesson because we can get straight into the exploration of this type of analogy. All right. Give me a second while I copy the table. All right. Whoops. All right. So here is the type of mutation, example, and effect. So there are three types of mutations that you have to know in this syllabus. Right. The first is the point mutation. So you will have the example here would be the substitution. So that means only one. So GAG to GTG, similar to what we did on the whiteboard. That may be silent, okay, missense or nonsense that you have seen. Then the second one will be insertion or deletion. So an example would be a frame shift mutation. So for example, the TAC would convert to TCA. So the effect is that it alters the entire protein. And then our chromosomal mutations is the final one. So then you have duplication, inversion, deletion, and the effect is that it can affect many genes. All right, so let me see if we can do mutated DNA sequences and have you transcribe, translate, and identify what happened here. All right, so if I give you, let's use a different whiteboard. If I were to give you GAGs to GTG, this is a point mutation, okay? So is this a missense, a nonsense, a silent, or a frame shift mutation? I'll give you a few minutes to think about it. So I do want you to look and refer back to your table for amino acids. So the universal genetic code is the place for you to identify the type of mutation. All right. So you have looked at your table and we can go over this problem. Okay, let's label GAG as the mRNA codons as CUC, and the amino acid would be glutamic acid. That would be GLU. And then with the GTG, let's go forward and take a look at, okay, not the draw tool. How do I, okay, let's, okay, select, okay, text, not that one. So when it becomes GTG, the mRNA codon is CAC. And then the amino acid here would be valine. So this would be VAL. VAL. Now, okay, perfect. So now I do want to impose something that you should look at. This is a point mutation. So specifically a missense mutation because one amino acid is replaced by another. So even though you only change one, so adenine to thymine, okay, you still change the entire amino acid. So this is very dangerous. Okay. This is actually very famous. So I didn't choose this by accident. I did choose this because it's a very famous example. So let me explain that to you. So that's very good. So I did see that you have identified the codon, you've identified the amino acid. So you have identified this as a missense mutation. All right. Now, let's go back to the document because then we can look at it as a famous example. All right. Okay, so you've probably heard about this. So have you heard about sickle cell anemia before? So, oh, okay. So you have been to Africa on a family trip. Okay, perfect. So sickle cell anemia is a very big problem in Africa. Okay, so this exact mutation, it causes the sickle cell anemia. Okay, the hemoglobin protein structure changes. The red blood cell becomes sickle shaped, leading to poor oxygen transport. However, the carriers gain resistance to malaria. Okay, and so that is a classic case of a mutation being both harmful and beneficial depending on the environment. Okay, what if we were to analyze another thing? For substitution frameshift mutations, let's try another example. So what if I were to change T, A, C to T, C, A? Okay, go ahead and look at your universal genetic code again, and I will get back to you with the answer. So think about the amino acid change and therefore the protein change, if there are any. Okay, so you have done so, and now we are looking at mRNA as the AUG codon. Okay, so the original DNA codon mRNA is AUG. So Very good. So that means you have always been aware that A pairs with T, G pairs with C. So that's very, very basic. So mRNA, so that's AUG. Now, the amino acid, okay, of methionine. So methionine is the start codon, okay? Now, with the TCA, you have the A, so then your mRNA would be your AGU, and your amino acid would be serine. Okay, let us do something else now. Okay, so this is obviously, okay, this is definitely what we did just now. So very, very similar to what we did in whiteboard 3. You are changing. This is also a missense mutation. This is obviously missense. Okay, so the functional impact, okay, when you have a start codon. Now, I want you to think about the start codon. If you are if what you are looking at is a start codon, so it's going to be starting the protein itself. If you change it to a serine, think about what the protein might look like. I'll give you a moment to think about that. Okay, answer time. I think the taste from here. Okay, so like I said, if you are changing the start codon to something else, it has a functional impact. Okay, the functional impact is if TAC is the start codon, then changing it to TCA means that there is no initiation of translation. So that of translation, which means that the protein won't function or won't form at all. So even when you change something like that, the protein won't form at all. Okay, so it effectively becomes a non-functional protein. Okay, so it is called a loss of function mutation. Now, if it is elsewhere in the sequence, okay, if it is elsewhere in the sequence, so when you say functional impact, it says here, if TAC is the start codon, then changing it to TCA means, all right, so that's what I said. Now, if it is somewhere else in the sequence, then methionine becomes serine. All right. Then now the protein may still fold, but its structure or function could could be altered like this. All right. Okay, that's enough with mutations and types of mutations. Let us get into the types of mutagens. All right, so now there are three types of mutagens that you are aware that you are required to be aware of. All right, so the first is the physical one. Then you have UV radiation that causes the thymine dimers. Okay, what do you think of specific to the context of Australia? Sunbathing, very good. All right, so let's use the whiteboard. All right, so if you are having, so if you have the sunlight, okay, and you have, so someone is sunbathing. So if you are having a person here, all right, and they are lying flat on the beach. So let's use blue. If you're having, then over here you have the water over here. So the sun's rays will fall onto the skin, okay, onto the skin. Okay, let's not use that. Let's use red. The UV light will go all the way to the skin and will cause cancer over here. On your entire body where you did not put sunblock. So that is so the thymine dimers are the cause of skin cancer. Okay. Then you have the chemical benzenes. So benzenes, so any sweet smelling aromas and the asbestos. So be aware of perfume being also potentially mutagen, asbestos, and then also the biological mutagens. So you have viruses. So you also cover this in another chapter on microbiology. But then here you have the HPV virus, the human papilloma virus, is one of the viruses that cause cancer. Right. So most mutations are neutral or harmful. Some are beneficial and fuel evolution. Okay. So it's a very popular question being asked. The key point here. Okay. So a very common question asked in exams is, are all mutations are harmful? Is that true or false? Okay. So that would be most mutations are neutral or harmful, but some are beneficial, okay, and fuel evolution. Okay. So now that we're coming to the end of our session, I do want to elaborate on evolution in action. So I do want to talk about antibiotic resistance as some homework for you. Okay, so I do want you to take a look at a case study called the MRSA. So it's the methicillin-resistant Staphylococcus aureus. So it's a type of bacteria that is a problem in hospitals. Okay, so you have to take a look at um, how the mutation confers the resistance, how it survives, how it reproduces, and how it spreads. Okay, so a very, very important discussion prompt would be, why are hospitals hotspots for rapid evolution in bacteria? Okay, so I want you to tie back to natural selection, mutation, selective pressure, and fitness. Okay, so I do want you to take a look at that before we get into questions. next class. So I did already assess how you looked at mutations and classified them based on the universal genetic table. But I also want to see how you're able to explain each question in the next session. Thank you so much for this demo, and I look forward to working with Crimson Education.